Hello everyone. In this video, I'm going to answer for you a question on vectors. The question is question 23 January 2017, paper 3H. The question is simple. It says that we have a trapezium ABCD and we have the side BC is parallel to AD, and in the same time we have AD is equal to 3BC. So we have AD is equal to 3BC, and we have AB vector is letter B, and BC vector is letter C. In order to answer this question, we have to remember some rules. First, we have BC vector is parallel to AD vector. But at the same time, AD magnitude or size is triple BC. From this, we have AD vector is equal to 3 times BC vector. They are parallel and in the same direction. BC vector is given letter C, so AD vector is 3C. This is the first quick proof from the diagram that AD is equal to 3C. Noting this, we continue our question to find CD vector. The question is find in terms of B and C the vector CD. So vector CD, we go from the point C to the point D. So we go in this direction. Let's say, for example, we go in this direction and then from B to A, and then from A to D. Also, we noted that AD is 3 times C. So we have AD vector 3C. Now, CD vector is equal to CB vector plus BA vector plus AD vector. We substitute. CB vector is negative C. BA vector is negative B. And AD vector is 3C. This gives me 2C minus B. So the answer is 2C minus B. This is CD vector. Now, the next part says that we have a point P. I will answer with a different color, blue color. So we have point P. P splits the line AC in the ratio 2 to 1. This means that AP is AP equal to 2PC. This is in terms of size. In other words, AP in terms of size is equal to 2 over 3 AC. In terms of vector, AP vector is the same direction as AC vector. So we can say that AP vector is equal to 2/3 AC vector. Now, let's go to our problem. Our problem says, is BPD a straight line? He wants to see if B, P, and D all lies on the same straight line. In order to verify this using a vector method, we know the rule. The rule says that if BPD will be a straight line, then BP vector is equal to a constant multiplied by PD vector. If this is satisfied, then BPD forms a straight line. We need to find BP first. What is BP? BP, I will go from B to P. This means that I will go in the direction BC vector, then I will add CP vector. If I simplify, BC vector is C. CP vector, what is CP vector? CP vector is a vector that is in the opposite direction to AC. So it is negative, and it is 1/3 of AC. So we have CP vector can be written as 1/3 of AC vector and negative 1/3 of AC vector because it is in the opposite direction. Now, if I simplify more, C minus 1/3, what is AC vector? AC vector, if you look on the diagram, if I go from A to C, I will go AB vector first and then BC. So AB vector is B and BC vector is C. C minus B/3 minus C/3. This is equal to 2C/3 minus B/3, which is 1/3 of 2C minus B. This is BP vector. Now, let's find PD vector. PD vector, what is PD vector? PD vector, I will go from P to C first, and then I will go from C to D. Or I can go in the opposite direction from P to A, then from A to D. This is much easier because I have AD is equal to 3C. So I will go from P to A. I will go from P to A. Then I will go from A to D. Now, P to A is negative 2/3 AC. How I know this? From the small deduction that we have done here, we have found that AP vector has the same direction as AC vector, and in the size it is 2/3 of AC. So AP vector is 2/3 of AC vector. Now PA vector is the opposite of this, so it is minus 2/3 of AC vector plus AD vector. AD vector, which we found it equal to 3C. So this is minus 2/3. AC vector, we know that AC vector is equal to AC vector. What is AC vector? AC vector, it is equal to B plus C. We go from A to C through B. So we add B vector plus C vector. We have here B plus C plus 3C. We simplify, we have minus 2B over 3 minus 2C over 3 plus 3C, which gives me minus 2B over 3 minus 1 over 3C. Minus 2C over 3, sorry, not minus 1, plus 7C over 3, plus 7C over 3. We factorize, we take a common factor here, 1 over 3, and then we have 7C minus 2B. Now, it is clear if we compare 1 over 3 2C minus B with 1 over 3 7C minus 2B, they are not equal. So from the comparison, we find that BP vector, it does not equal a constant multiplied by PD vector, which means that BP vector is not a multiple of PD, which means that BPD is not a straight line. Also, like this, the problem is solved. But for the interest of others, if you see BP vector, you will find it 1 over 3 2C minus B. If you look to CD vector, you are going to find it also 2C minus B. So the vector CD, which is 2C minus B, is equal to a constant which is 1/3 multiplied by BP. From the diagram, we can see that CD is parallel to BP. So it is impossible that BPD becomes a straight line because CD is parallel to BP. But this is another way of proof. If you have a sharp eye, you will observe that 2C minus B is common between BP and CD. So this means that CD is parallel to BP. So from this, it is impossible that BPD is a straight line. This is another proof. I hope you like this question and like this video. Please don't forget to share and let me know your comments and subscribe. Thank you and wish you a nice day. Bye-bye.